Today we're going to actually graph some logarithmic functions. There's a few things on here that we need to talk about, a few things that we can skip. If we're looking at the generic function y equals log base b of x minus h plus k, because it's a vertical asymptote, the asymptote is affected by the side-to-side movement, which happens inside the parentheses. So the minus h is going to give us the asymptote. And the asymptote is going to be x equals positive h. It's going to be the opposite of whatever number is in there, because minus h actually moves to the right and plus h would move to the left. The domain, assuming that there's no negative in front of the x, is going to be x is greater than whatever that asymptote value is. And the range, that's the easy part, the range is all real numbers. And on the test, you can just use a capital R for all real numbers. That will suffice. Okay, using the calculator, I used to really stress this because we had graphing calculators at our fingertips in class. We don't this year. So we're actually going to be using Desmos instead. I think Desmos is the most attainable for everybody. So I'm just going to write down the address, www.desmos.com. That's S's, Desmos.com. That's what we are going to be using to help us graph. This change of base formula we've already talked about. If you want to evaluate a logarithm on your calculator, you do log button, the number that's inside the base, so the number that is in line, same size, not the base, divided by log, the log button, and then the base. And as long as you close your parentheses, you're good. So on number 10, you would do in your calculator log button 15, close your parentheses, divided by log button 6, close your parentheses, and that would tell you what the log base 6 of 15 is. So log button 15 divided by log button 6. Make sure our parentheses are closed. You should get 1.511. Why don't you try number 11 on your own? It would be log of 7 divided by log of 3, 1.771. Okay, now the reason that we used to do this is I used to make students pick x values and plug them into the calculator and find the corresponding y values. In the age of Desmos, we are definitely not going to do that. We are going to go to Desmos and type this equation into Desmos. And then we're going to have Desmos tell us a couple of points that we want to use that we can then put on our graph and connect them. So we're going to go to Desmos. So pull up a browser. And I'm going to type in www.desmos.com, Desmos.com. We click on Graphing Calculator. Now, you can get to the log features by clicking on this little keyboard at the lower left, and then going to Functions, and then going to MISC. But that's a lot. Like, getting there's a lot when you really can just type it. So you can type in f of x, or you can type in y equals, it doesn't matter. So f of x equals or y equals, it does not matter. Our equation was log base 2. So type in log, then shift dash. Shift dash, that's the button that's right next to your plus equals up at the top. That gives you underscore, which lowers it down into the subscript. So you can type in that it's a base of 2. Then you hit a right arrow to get out of the base. Parentheses, x minus 2, close the parentheses, plus 3. So hopefully you notice that this part of our equation in Desmos looks exactly like it does on the paper. If it looks different from how it looks on your paper, you probably typed something in wrong. Ask me for help. I'll help you out with how to get that typed in. But now you can look at this graph and figure out a lot of information. If I do ask you to actually graph it, the one thing that I really, really don't want you to do is go, "Nip, there we go." That drives a math teacher completely up the wall. Like a cat clawing the walls and climbing to the top. Like it's like a cat is like clawing at the walls of my brain right now. That's awful, terrible. But in Desmos, we can have it tell us some of the points. I mean, we could kind of guess on some of these points, but we can also have it tell us the points. If you go to this little settings wheel, it says Edit List. Click on the settings wheel, and then it gives you some options next to this. And the first option is Convert to Table. Now, it's giving us a bunch of undefined. Like, oh, shoot, this isn't helpful. But if you click at the bottom of that table, you can tell it whatever x values you want. So I could type in 3. I could type in an x value of 4, an x value of 5, an x value of 6, and I can keep going. And we can pick any of these points. Undefined means that those x values are to the left of the asymptote. So those x values don't work at all. 3 is the first x value that works. So we have 3, 3. And I'm going to write these down on my own paper. 3, 3, 4, 4, and then 5. That's like 4.6. And then I'm also going to write down 6, 5. So I'm going to write down like 4 points. So here I've got 3, 3, 4, 4, 5, 4.6, and 6, 5. So 3, 3, 4, 4, 5, 4.6, and 6, 5. Now these points still don't look like much. You need to remember your asymptote. This graph moved right 2, so our asymptote is going to be x equals 2. So at 2, I'm going to draw in a dashed line to help me. It's going to curve up through these points, and on the left side, it's going to keep getting closer and closer to that asymptote. All of the points are on the right side of that asymptote, so x is greater than 2, and our range is all real numbers. We're skipping to number 4 for 2 reasons. First of all, there's a negative in front, so we can see what that negative does. The second part is this is an ln function, so I want you to see how to graph ln in Desmos if you need to. So in Desmos, you can click this little x and just get rid of that graph that we already did. This one is f of x equals, or y equals, -3. You can just type in -3. ln, and it automatically makes that into that little ln function, parentheses, x minus 1, close your parentheses, plus 5. What I love about Desmos is that you really can just type that equation in. You don't have to know any fancy buttons, you just use your keyboard. Okay, quick review, how to get the points. Click on the settings wheel. Oops, I've moved my graph around. Settings wheel, and then convert to table. And you will have some undefined because there is an asymptote. This asymptote is at x equals 1. So at 1 and anything less than 1, the function is undefined because that's the left side of that asymptote. So 2 is the first point that we can use. I want more, so I click underneath the 2, and I'm going to type in 3. And then if you just keep hitting enter, it will automatically put the next few in there. Now, do you need to use all of those? No, you don't need to use all of those. But I've got the 0.25, 3, 2.9, 4, 1.7, and 5.8. So I grabbed the points 2, 5, 3, 2.9, 1.4, 1.7. And if you're thinking, oh my gosh, all of these are gross looking decimals, this is ln. With ln and with log, you're not going to have nice, pretty, perfect numbers. You're going to have decimals. That's totally fine. So 2, 5, 3, 2.9, that'd be almost up to 3, 4, 1.7, be there-ish, and then 5.8. Our asymptote is going to be at positive 1. And with Desmos, you can get an idea of what this graph looks like by looking at the picture. It starts close to the asymptote up at the top of the graph, and then it's going to curve down and to the right away from that asymptote. So it's going to curve down and to the right here, and it's looking like it's going to flatten out eventually. And then up here, it keeps getting closer and closer to that asymptote. It's still on the right side of the asymptote, so our domain is x is greater than 1, and our range is all real numbers. Probably on the test, it's going to be very similar to the last test where it'll say asymptote and it'll say x equals, and then there'll be a blank. For the domain, it'll be x and a blank, and you'll have to type in the 1 and then greater than 1. And then for range, it will just have a blank, and you'll have to type in a capital R. So I'm guessing it's going to be very similar to the last test for how you type that in. Okay, your assignment today is worksheet 3. On worksheet 3, there are 2 graphs, log base 5 and log base 3. Use Desmos to help you with those graphs. Graph it in Desmos, grab some points, put it on the graph to the best of your ability. State the asymptote, domain, and range. Then 3 through 6, you're just looking at the equations and finding the asymptote, domain, and range. If you want to use Desmos to help you with that, you absolutely can, but I'm hoping that you don't need to. And I think your worksheet is just the front side of that. It's just one page, numbers 1 through 6.